Okay, you're welcome once again to our mathematics meal, a program that is beautifully and wonderfully helping students in the study of what? Of mathematics. Now we are still on plane geometry 1, and so far we have looked at the meaning of geometry, types of straight lines. We have also looked at types of angles. Now, in this episode, we are going to consider the concept of a relationship between angles and what? And lines. Relationship between lines and angles. Now, these relationships, they are very, very important in the study of lines and angles. Most of the calculations that we do, we center on these relationships. So we are not going to joke with them. We must master them. There are valid relationships that you must know if you are going to carry out calculations between lines and angles. So if your calculation is not based on these valid relationships, then you are wasting your time. So let's quickly look at them. So we begin this way. Relationships between lines and angles. What are these relationships? Number one, using a straight line, sum of adjacent angles on a straight line is 180 degrees. So what we popularly say sum of angles on a straight line is 180 degrees. So using a straight line, sum of angles on a straight line is 180. So this is a straight line. This is a straight line. If I have angle A and I have angle B, the sum of A plus B will give me 180 degrees. This is a straight line. Sum of adjacent angles. Angles that lie side by side will give us 180 using a straight line. Look at this. How do I know it's a straight line? If I have this, I started and I have to end here. If you have something like this, it's not a straight line because when I start here, I did not end on the line I started with. But if I now do this, it now becomes a straight line because I'm ending here now. So, this is a straight line. It's not a must that the straight line will be horizontal. We can still have a line like this. We can have a line like this. And we have this and that. And here is x, here is y, here is z. So x plus y plus z will give me what? 180. Even if it's facing downwards like this, we have that and that. I add this, this, and this. Maybe P, Q, and R. So P plus Q plus what? R will give me what? 180 degrees. 180 degrees. So sum of adjacent angles on a straight line will give us 180. Point taken. It's a valid point in geometry. The second relationship is this: sum of angles at a point is 360 degrees. So when lines meet at a point and you add the whole angles there, have A, B, C. If I add A plus B plus C, it will be 360 degrees. If I have this, and I have that, I have x and y. X plus y will give me what? 360. So if I can draw a circle, that's the point now. If I can draw a circle around the sum of all the angles around that point will give us what? 360. It's another important point. So when you want to do calculation of angles on lines, this is one of the rules, or one of the valid points, valid arguments, one of the important points that our calculation can center on. This is one of the bases. So if you now check a figure given to you and you discover that there is a straight line and there are adjacent angles, then you can apply this. But if you discover that you have angles at a point, you can apply this second point or second rule. Then number 3, we can say that sum of angles formed by perpendicular line. We say sum of angles on a perpendicular line formed by perpendicular line. So if we have the perpendicular lines, the sum of angles that we're going to have here will give us 90 degrees. So sum of angles formed by perpendicular lines is 90 degrees. Sum of angles formed by perpendicular lines. So let's look at this. If I have this, and this is a perpendicular line, supposing I have it and I have that. So we have this. So sum of the angles formed by perpendicular lines is what? 90 degrees. So the sum of angles, these two lines are perpendicular. So if I sum the angles formed by perpendicular lines, we are going to have 90. So x plus y will give me what? 90 degrees. If these lines are what? Perpendicular. That's if these lines are perpendicular. So the sum of these angles will be what? Will be 90 degrees. So sum of angles at perpendicular lines will give us what? 90 degrees. So the perpendicular lines are lines that meet at what? 90 degrees. So sum of all the angles at that point will give us 90 degrees. So number 4, we say that vertically opposite angles. So we can say using vertically opposite, using intersecting lines, we can say that vertically opposite angles are equal. Vertically opposite angles are equal. So using intersecting lines, vertically opposite angles are equal. These are rules that will help us solve problems. I have M. Let's say here is M, here is M, here is X, here is Y. Here M will be equal to M and X will be equal to Y. Why? They are vertically opposite angles. They are vertically opposite angles. So using intersecting lines, vertically opposite angles are equal. So this angle is equal to this. So if this is 50, this will be 50. If this is 1 million, this will be 1 million. So vertically opposite angles are what? Are equal when we use intersecting what? Lines. So these are valid points. So when you want to do calculation in of angles that are on lines, you must check. One of the bases of the calculation is to check whether what I want to calculate, the known angles and the unknown angle, whether they are related by this rule, whether they are related by this rule, whether they are related by this rule, whether they are related by this rule. One of these must work. For all the basic rules that we are going to look at is not applicable, then it's not possible for you to just do anything. Then we'll now tell you what to do when you have checked and you discover that the angles, they are not angles on a straight line, so there is no way I can find the what? The unknown. They are not angles at a point. There is no way I can find the unknown. They are not angles formed by perpendicular lines. How will I find the unknown? They are not intersecting what? The angles formed by intersecting lines. How will I use vertically opposite angles? If you check and none of these valid points can be used to connect the unknown and the what? The known angles, then there are other things you can do in order to establish such what? Relationship. But don't just go about when you check there is no direct relationship between the known and your known angles, then you now manufacture something and do anything you want to get an answer. No, that will be unmathematical and anti-mathematics, to be against mathematical rules. So we still have some to look at before we conclude. So we now say using parallel lines. Using parallel lines and transversal lines. A corresponding angles are equal, and also alternate angles are equal. So we cannot talk about sum of adjacent angle on a straight line except we have what? A straight line. We cannot talk about angles at a point except we have a point, like we have here. We cannot talk about angles formed by perpendicular unless we have perpendicular lines. We cannot talk about vertically opposite angles except we have intersecting lines. So you see the things to check out when you want to do a calculation, when you want to carry out calculation. Then we cannot talk about corresponding angles and alternate angles if we don't have parallel lines and what? Transversal what? Lines. You see that? So we are still on this relationship. Now let's explain corresponding angles and the alternate what? Angles. Let's explain corresponding angles and the what? Alternate angles. Let's look at it from here. Let's say I have a straight line like this that is parallel to another line like this. Then I have a transversal. This is parallel. You remember we say we use arrow to indicate parallel lines. Now a line that crosses parallel lines, we refer to that line as what? Transversal. You know, somebody can still draw this like this and draw the transversal like this. You can turn it this way to look like this so that you can easily do that. Or you bend with it to actually study it. You can actually bend like this or turn your paper in that form so that you can actually study if these lines are parallel. You know, staying like this will cause problem for your neck. So you just turn the paper when you have such a question so that it will be in a form that you can easily view. Okay, so this can occur in different forms. That's the parallel lines. So now let's say that we have this. Let's indicate some angles. Let's say I have A, I have B, I have C, I have D, I have E, I have F, I have G, I have H. All these are angles. Okay. Now there is something that happens whenever you have parallel lines and transversal lines. These two lines are parallel, while this one is a transversal line. We generate two angles we call alternate angles and what? Corresponding angles. Now, how are we going to explain this so that you understand it? Let's look at it this way. Now, this is a parallel line. This is a parallel line. This parallel line has top and bottom, right? So we have up and down. Let's use that. Up and down. So when you have a parallel line, there are angles on top of it, there are angles under it. Then we have up again and we have down. So we talk about two things here. We are going to look at position and we talk about side. That's what happened. Now, when you now bring in a transversal line, we now have the right and we have the left. So you see this transversal line that divides this into two sides. So position, we have up and we have what? Down. Then we have right and we have what? Left. Okay. We'll pick few angles to illustrate that. Now let me start with angle A, for example. So look at our angles now. Look at our angles. And then I talk about angle A, which is this angle. What is the position of A? What is the position of A? Let's see the position of A. A is up. So A is up. Angle A is up. That's up on top of the what? Of the parallel line. That's here on top. Now what is not down, so this position is this, so it's not down. What is the side? Is it right or left? A is on the right. So A is on the right. Let's take another one, angle E. Now see what happens. What's the position of E on this parallel line now? E is on top. Remember, every parallel line we have up and down. So E is still up, so it's not down. Then, which side? Say what? Right. Oh, beautiful. Now let's do two more angles, then we now conclude. Now let's look at B now. B is still up, right? And the well, now on the what? Left. Okay? Then let's talk about F. F is still up and still the same here, left. Okay, we want to talk about corresponding angles. Now, two angles are corresponding if they occupy the same positions and they're also on the same sides, on their respective parallel lines. So, if I have A, I can say that A is equal to E. Why? They are corresponding angles. Also, B is equal to F. Reason, the same reason here. They are corresponding angles. Okay, let's write it in full. We still have our marker. So B is equal to F. Why? A is on top on the right, E is on top on the right. The same position, top, right, corresponding angle. B is on top on the left, F is on top on the left also. Top, two of them, left. They are corresponding angles. So once you discover their position and their side, you can use it to know corresponding angle. The same thing if you look at C and G. G is down, C is under, so down. If we talk about C now, the position of C is down, but its side is what? Left. If you look at G now, G is also down, and the side is also left, it's on the left. So G is also corresponding to what? To C, because C is down, this is down, the same position. This is on the left, this on the left, the same side. So they are corresponding angles, because they occupy the same they occupy the same position, and also they are on the same side. So we call them corresponding angle. Very important. Make sure you master how to identify or dictate corresponding angle. Now, if we look at it, some people call it F angle. You look at it under. It's like F now. It's like F. So, all right. Now, if we want to pick alternate angles, now we still look at angles. We look at position, then we look at side. So let's talk about angle C. Angle C is down, under, and then on the left. Let me talk about angle E. E is up, but on the right. Let me talk about D. D is down and on the on the right. Then let me talk about F. F is up and on the on the left. Now when they are on different sides and different positions, we call them alternate angles. Alternate angles. That's, we'll say this. Now we can say that C is equal to E. Reason, they are alternate angles. Then D is equal to F, reason alternate angles. Y, different position, different side. Look at C. C is down and left. This one is up and right. So the side down, up, different what? Position. Left, right, different what? Different sides. We usually call alternate angle Z angle. So let me draw Z in the normal way. Look at that. This one is up on this line. This one is down on this line. This one is left. This one is what? Right. So when two angles occupy different positions on different sides, you call them what? Alternate angles. So look at this. This is alternate to this Y. This is under. This up. Different what? Position. This one is on the left. This one is on the right. Different what? Sides. Remember, it is the transversal line. The transversal line that we actually separate them into different what? Sides. So by drawing a transversal, we have the right side and we have the what? Left side. And then on the parallel, we have top and the what? Down. And this one again, top and down. So if their positions are the same and their sides are the same, like we have the up, up, right, right, then they are corresponding. If their positions are the same and their sides are the same, like we have the up, up, left, left, they are what? Corresponding. But if they have different positions, different sides, then we call them what? Alternate what? Angles. And corresponding angles are equal. Alternate angles are also what? Equal. Wow. These are the valid points that we need to take note of. They are the valid points that we need to take note of. About 5 of them or 6 of them. Angles on a straight line are equal. Sum of angles at a point is 360. Sorry, angles on a straight line will give us 180. Sorry about that mistake. Then sum of angles, adjacent angles on a straight line is 180. That's the first one we looked at. Sum of angles at a point is what? 360. Then we say that angles formed by perpendicular will give us what? 90 degrees. Then we say that vertically opposite angles are equal when we use intersecting lines. Then we say when we use parallel lines and transversal lines, we're going to see that corresponding angles are equal and alternate angles are equal. So anytime you want to find an unknown angle on lines, only these rules and any other relevant rule that you may see based on the equation, maybe you are told that this line bisects an angle here, it's another relevant rule. But these are the basic rules that we use. If you cannot connect angles using any of these rules, then you are off. You are off. Yes, the angles that are known and the unknown angles must be connected by any of these rules that we have mentioned. Either they are adjacent angles on a straight line, or they are sum of angles at a point, or they are vertically opposite angles, or they are angles on a given perpendicular, or they are corresponding or what? Alternate. Please, it is important. This is the basis of geometry. You cannot calculate angles without knowing this word, this important point. You cannot. It's not possible. This relationship between lines and angles, very, very important, because that's what forms the basis of our calculation. Anytime you have an unknown angle and you have a known angle, what you look at is what's the relationship between the angles on the line. Are they angles on a straight line? Are they angles at a point? Are they corresponding angles? Are they vertically opposite? And these are things. You must establish a relationship between the unknown and the what? Known. If you fail to establish this valid relationship, then anything you are going to calculate will just be panel-beating. It means you are panel-beating mathematics. You just want to do a lot of abracadabra in order to bring out an answer. All right. We shall be back to now look at the important points that we must take note of whenever we are doing calculations of angles on lines. Remember, you can play this video over and over again until you have taken notes of all the important points. Don't hesitate to ask questions. Don't hesitate to give us feedback on the videos that you have watched so far, to know if there are some explanations that are not very clear. that you did not understand, we will do well to run another video to clarify it. Thank you as you continue to watch Mathematics Meal, and as Mathematics Meal continue to drive away mathematical foolishness and stupidity from people. Thank you and God bless you.